Today's lesson is about adding and subtracting linear expressions. And to begin today, we're going to start with our warm-up, where we have to simplify each expression by combining like terms. When we combine our linear expressions today, this is essentially what we're going to be doing. We're just going to start looking at things in a little bit of a different view. So pause the video, complete the warm-up, and then come back and check your answers to make sure you're understanding how to combine like terms before going forward. So if we look at our answers for this warm-up, number 1 and number 2, the first one, when I combined my like terms, I initially got negative 1x plus 0. But we don't really actually have to write 0. And negative 1x could just also be written as negative x. If you wrote your answer as negative 1x, that's okay as well. And for number 2, remember we first have to distribute this negative 1 that's sitting out front. And then after that, we have to pick out which are our like terms. And when I actually combined my like terms, I ended up with 2x plus 2. So our most important definition that we're going to talk about today is exactly what is a linear expression. And so if you read below, it says a linear expression is an algebraic expression, so that means we're going to have letters and numbers, in which the exponent of the variable is 1. Maybe we should highlight that. So the exponent of the variable is 1. If we have an exponent and it's not 1, it's not linear. And so if we look at these examples, we have linear expression examples here. Negative 4x. We have to make sure the exponent is 1 on our variable. Notice when we look at this x, there isn't actually anything written. And if there's nothing written, we can assume that it's a 1. So it would be linear. Here's our variable 3x, and because it's not written, we know it's 1. Then in the third example, our variable is with that negative 1/6, but there's nothing written, so we know the exponent's 1. If we look at these nonlinear expressions, notice here we have an exponent of 2, so it couldn't be linear. In the next example, this x has an exponent of 1, but the other x does not, and because there's something bigger than 1, it doesn't work. And in the third example, I see an exponent of 5, so that doesn't work as well. And so that's why those are nonlinear versus the first 3 we looked at. And when we combine linear expressions today, we can add them either horizontally, which means across the page, or we can add them vertically, so up and down. You might have a preference, or you might like them both, but you'll get to choose which ones you like after we practice both different methods. So on this first page, we are going to add horizontally and vertically. So if we look at this first one, we're given x minus 2 plus 3x plus 8 in part A. And it teaches us that the vertical method, so that means up and down, is align your like terms vertically and then add. So they took x minus 2, and right underneath it they stacked 3x plus 8. Notice our x's are lined up, and our constants, or numbers, are lined up. Once you make sure everything's added or lined up correctly, all you need to do then is simply add, because that's what we're doing in the original problem. So I have 1x plus 3x gives me 4x's plus negative 2 plus 8. Let's look at this. Negative 2 plus 8 gives me a positive 6. And right there I have my answer. Notice it's essentially just combining like terms. When we line it up horizontally, like in part B, remember that goes across your page, we're going to use operations and group our like terms. So when we're adding together, notice they have it laid out horizontally. Remember, parentheses don't matter, so why don't we rewrite it without the parentheses? Negative 4y plus 3 plus 11y plus negative 5. Notice what I did there. I took my minus and wrote it as plus and negative. And then we just go ahead and group our like terms. I have 4y and 11y. Then I have a constant and another constant. And when I go ahead and combine them, negative 4 plus 11 leaves me with 7 y's plus 3 plus negative 5 leaves me with a negative 2. And I get an answer of 7y plus negative 2. So remember, when we are adding linear expressions together, we're really just combining like terms. We actually haven't done anything different than what we've been practicing. So go ahead, pause the video, and give these 3 problems a try. Just remember that when you get to number 3, we're going to also have to use the distributive property before we start combining terms. So if we look at our answers for these 3 problems, number 1 got us 3x plus 2. Number 2, our z's actually canceled, so we had 0 plus negative 3, but we don't need to really write that 0 plus, so our answer is just negative 3. And number 3, we ended up with negative 11n plus 10. Our next few slides are subtracting linear expressions. And I'm going to be honest, subtracting is a little bit harder, but as long as you work carefully, you'll make sure you get it right every time. So when we find the difference using vertical method, so remember that's up and down, we're going to start just the same way. We are still going to stack our x's and our numbers. So if I have 5x plus 6 on top, underneath it, I'm going to stack my minus x plus 6. But we're subtracting these expressions. Now, if we're leaving this as subtraction, I bet 90% of us are going to make mistakes. So what we need to do is we need to find the opposite of the expression. So what we have to do is we have to multiply by that negative 1. And so if we actually go up here and multiply by that negative 1 that would be there to this expression on the back end, if we distribute it, we change it into addition, which is kind of nice. So we can take this problem and change it into 5x plus 6 plus negative 1 times the negative x is positive x. And negative 1 times positive 6 is negative 6. So we can change it right back to addition, and we can still do it vertically. 5x plus 6 on top, stack our x's and our 6's. And then when we go ahead and add, it makes it a lot easier. Because we're going to have 5x plus 1x is 6x. And then 6 plus negative 6 cancels. And so we're left with just a 6x. However, if you would use subtracting, I bet we would make some mistakes and not get there. And so what I like to do is when we are taking the difference, if we distribute the negative, we're going to make it back into an addition problem. And addition was pretty easy. And so in this next one, we're going to use our horizontal method. Just remember, horizontal goes across our page. And what I'm going to start with, I'm going to start by distributing my negative 2. So make it plus and negative, and then I'm going to go ahead and distribute. So I have 7y plus 5 plus negative 2 times 4y is negative 8y plus negative 2 times negative 3 is a positive 6. Put an extra plus in there, so we'll get rid of it. And because I changed it into addition, we don't need parentheses anymore. And the beauty is now we're back to what we've been doing. 7y minus 8y, they're like terms. And then 5 and 6 are like terms as well. And when I combine these, 7y minus 8y is negative 1y plus 5 plus 6 is 11. If you want to get even further, you could write negative y plus 11, but both of these are totally acceptable answers.